Hello everyone and welcome back to our channel circuiTician. Today we have something truly exciting for all the electronics enthusiasts out there. We are going to build a unique ID generator using the CD4017 IC. Unique ID generation for the sensor is crucial for ensuring the accurate identification and tracking of individual sensors. It not only enhances security, it also prevents data mix-ups in IoT and industrial applications. Now, if you have ever wondered how to create unique identifiers for your sensors and actuators, you are in the right place. So, let's get started. But before we get started, if you are new to this channel, don't forget to hit that subscribe button and give us a thumbs up if you enjoy this video. Alright, let's begin by understanding how the CD4017 IC works. The CD4017 is a versatile integrated circuit that can be used for a wide range of applications. It's a 10-stage decade counter with 10 decoded outputs. But what makes it particularly interesting is its ability to generate unique sequences, making it perfect for creating unique IDs. When you apply a clock signal to the clock pin of the CD4017, it starts counting. With each clock pulse, the CD4017 advances its internal state. For example, when you apply the first clock pulse, the Q0 output goes high. For the second clock pulse, the Q1 pin is high. It then proceeds to count through Q2, Q3 and so on until it reaches Q9 and then it resets to Q0. This cycle repeats for every clock pulse, creating a decade counter. As the CD4017 has 10 output pins, that means we can have up to 10-bit unique IDs. Now the idea is like this, that the output pins of the sensor is directly connected to the microcontroller. But it will only read data from the sensor if unique ID of the sensor is matched with the predefined unique ID in the microcontroller program. Each sensor contains a unique ID of 10 bits. This identity is created by short-circuiting specific output pins of a CD4017 decade counter together. The microcontroller sends 10 clock pulses to the CD4017 and after each clock pulse, it reads the detect pin. Now the pins that are shorted together, those pin produces high output for the corresponding clock pulse. So that's how we get the 10-bit unique ID. As you can see in the schematic, here D0, D1, D2 and D4 pin are shorted together using diode. So I am writing 0, 1, 2 and 4 bits as 1. And that produces a ID of 23 if you use binary to decimal conversion. Here is the PCB design of the schematic. You can get the link in the description. Alright, now let's look at the actual hardware. As a sensor, we are using a LDR. And one more thing to remember, that when you are shorting the output pins of the CD4017, you have to use diodes for unidirectional signal. It also prevents signal mix-up. We are using an Arduino UNO as master unit. Alright, now let's understand the programming algorithm. At first, we define our sensor ID, which is 23. It is predefined in our code. Then, we send a reset signal to CD4017 to make sure it starts counting from 0. Then we initialize a for loop which is starting from 0 and ending at 9. That means 10, because we have 10 outputs in CD4017. In the loop, we first send a high pulse to the clock-in pin of the CD4017. Then we check if there is any output coming from the detect pin. If it is 1, then we use this formula to convert it to decimal. If not, then we use ID equals to ID. After 10 rotations, we will have the ID. Then we match it with the previously defined ID. If that ID matched, then we start reading from the sensor. This is very simple algorithm. All the codes will be given in the description. You can check that out. And if you have any question regarding the algorithm, then you can comment it down below. Now let's see the working of the whole system. Now I am plugging a sensor package to the Arduino. Connecting the Arduino to the laptop. Now let's check the ID of the sensor package. Here you can see it is 15. Now let's connect another sensor package to the Arduino to check for its ID. It is connected. And as you can see, this sensor package ID is 23. Now here in the code we have defined our predefined sensor ID as 23. Now let's connect a sensor package to the Arduino. Now here you can see the ID is 23 and it is matched, so it will start reading from the sensor. Now let's connect another sensor package. As you can see, the ID is 15 and it is not matched. That's why it is not taking reading from the sensor. If you enjoyed this video and want to see more exciting content on electronics, IoT and robotics, don't forget to subscribe to our channel, like this video and hit that notification bell so you never miss an update from us. And if you have any queries, then let us know in the comment section. So see you in the next video. Until then, be creative.